Hello everyone, I'm Alex, and today I'll be introducing our team's project, the Wapets v2.0. How do we search for something on the internet? You open your browser, type in what you want to search for, hit enter, and you've got your result. But what if you didn't know how to use a browser? For people unfamiliar with technology, especially more elderly people, this common issue drives them away from wanting to interact with most present-day technology. So how can we solve this? Our solution to tackle this is the Wapets 2.0, an augmented reality pet simulation app that puts helpful, user-guided pets into our pockets and onto our screens. Using virtual pets as the basis of our project encourages the elderly to be engaged whilst keeping them connected with the outside world. But using just pets is not enough to solve the issue at hand. This leads to the key requirements of our project. To create a one-stop user experience, we set out to include the following requirements and must-haves. The product will have a holistic user experience which we hope will help users have fun with virtual pet interactions while familiarizing them with the common technologies that we use in our daily lives. Our project has two parts. The first uses Unity and Unity's AR toolkit to develop and control the AR pets for both mobile and desktop, and the other is using Python and Django to store user preferences and pet information, along with IBM's Watson to incorporate speech-to-text and text-to-speech functionality, so that the pet can assist users on matters ranging from retrieving the local daily news to searching for their favorite media. We've developed a diagram to show how the project is structured and how the different parts interact with each other. As you can see, both the mobile and desktop versions of our application use a common Wapets API, which interacts with the backend server to send and receive user information, as well as Watson to do text-to-speech and speech-to-text.
We'd now like to demonstrate the functionality of our project. The magic that makes our app work is visible in the thing here. The example message, along with other similar ones sent and received by the backend server, is what is used to store user and pet information, authenticate user login, and synchronize pet data to different clients. A second part is the desktop app. This is the login page I designed, and will load to the desktop assistant app. Here's the assistant part. The demo was shot in Unity so you can see the Unity log console to better visualize how it works. And this is the desktop pad, sitting idly in the bottom right, reacts to different types of interaction and can be dragged around the screen.
How are you?
The speech bubble shows up if it says something. The pad also has an Easter egg interaction. Take a try at the app and see if you can find it out. This part is for customization of voice controls. You can do that by adding the voicecontrol.csv file under resources folder. And I've added the openbbc command and see if it works. OpenBBC.
Bye.
And there are also several useful gadgets on the desktop UI overlay. The next demo will be our implementation of AR. Users can interact with pets, play games, feed, and etc. User gestures are recognized using motion input, and pets respond to the corresponding user gestures. Not only have we developed the actual app for the desktop and for the mobile, but we also provided plenty of APIs and documentation for future developers. The server part is here, as I mentioned before. This is the C# API for the desktop client, and this is the overall project documentation that is available in this GitHub repo here, with detailed installation process packages for Unity developer, and there's an executable file under the build folder. Thank you for listening. We'd love to hear your thoughts and questions on the project.